Hello, React India. I hope you guys are awake after that lunch, and I hope you continue to be awake throughout my talk. Okay, so let's get this started. I'm Prateek Bhatnagar, and I work on Google Chrome. I work with a team called Web SDK, and our aim is to make web ecosystem better, like whatever it takes. We don't have a set product. We don't have a set library framework. We just pick stuff, what we see that's not working for web developers or web ecosystem, and we go and try to fix it. That's my day job, though. By the night, I'm a part of this amazing open source project called Preact, and I find it really interesting. How many of you guys have used Preact? Okay, nice, yes. For the people who who have not used Preact, it's a 3 KB library which has the same modern API as React. And the reason it's interesting for me is that the amount of stuff that it allows you to achieve within that small, tiny footprint of 3 KB. Like it's literally 3 KB, and you can do most of your work that you do in your React.js with the same API. Okay, and I am talking today about how this ecosystem is evolving, is changing, and how it's changing for better. So today I'll be covering 3 packages from this ecosystem, 3 main packages that the core team or members of core team maintain and are very essential to this ecosystem. First up is the core Preact library, how this library is changing. Second up is Preact CLI. Preact CLI is our meta framework. You can imagine it like similar to Nuxt or Next or Gatsby, and it's our meta framework that scaffolds a Preact-only project for you. And the third would be Preact material components. This is something that I started, and it's a wrapper over the standard Google Material Web Components library for the Preact users. So like, you don't have to wait for, you don't have to wait for a wrapper for your Preact components to use this particular material design. And also that you don't have to use somebody else's implementation, which is an inferring of what material guidelines is. The material components web is this project by Google itself that implements all material components. And Preact material components is a small wrapper, very tiny wrapper around it, so that you can use all the APIs declaratively and do not have to do imperative work on that. Okay, first up, Preact. As I said, it's a 3 KB VDOM library with the same modern API. It has your JSX, it has your classes, it has your same component lifecycle, and a lot of other stuff that we are going to just discuss. Okay, just a little bit of history. Preact was started by this guy. This guy is Jason Miller at _developit on Twitter. A very friendly and very humble human being. If any of you guys are starting open source contributions, go and look up one of his projects. He's like extremely helpful. And that's how I started my open source journey as well. So he wrote this CodePen library, CodePen. He wrote this CodePen. Like this is approximately some 700 lines, and he tried to mimic the whole API of React in this like 800 lines of code. So this was how Preact was born, and this is where it lived for a few months before he went out and published Preact first version, V1. And then a lot of us joined with this aim, like this is really nice if we can do all of that work that Preact and Preact DOM does within just 3 KB. So a lot of people joined him, and there was a journey where it came till Preact 8, which is the current stable version. All was well and good in the ecosystem with Preact 8 until React 16. So like the API was same, the component lifecycle was same, everything that React gave you, Preact also had a counterpart of it. So like you could literally write your code in React, and for the production bundles, you could take out React and alias React with Preact. That's how a lot of major companies publish their websites. And I'm talking like big companies. What they did is like all their team wrote React components And at the production time, they just swapped React with Preact. And voila, smaller bundles. But came the problem. There came hooks, suspense, error boundaries, fragments, array returns, and a lot of other things which make the whole community sad. What happened is like we suddenly had this gap where Preact was giving you a lot of things which React was giving you a lot of things which Preact was not. And the Preact core team tried a lot. Like there was around 6 to 8 PRs where we tried to make these things happen with the current code base. But like the current code base, the decisions that we made did not just made it possible for us to implement these features within that 3 KB limit. So thus, Preact X was born. Preact X, code name Ceviche. The whole Preact core team gathered around and decided to throw everything away. Like, we just started with a blank repository, and we started a major rewrite from ground up. We introduced a more uniform diffing system, like all the edge cases that we handled at different points. Now we handle it very early in the life cycle, and then like the whole diffing system is very uniform. This helped us shave a lot of bytes from the end product. We also introduced a new option system where like you as a developer and we as core team members used it and implemented hooks. So now you have access to each and every life cycle that your component goes through. That's how we implemented hooks, and it's just like all the hooks are just 900 extra bytes if you use it with the core Preact library. We also did a new renderer. What happened to happen earlier was Preact used to diff your actual DOM against the next state of the VDOM. This slowed us down somewhat. We are very reliant on the DOM. Like Preact is a DOM-only library so far. There's no like Preact native, or there's no Preact WebGL or anything like that. We rely heavily on what platform gives, the event system of the platform, the DOM, and everything. So this new renderer, instead of diffing your DOM to the next VDOM, is now just diffs the current VDOM and the next VDOM. So if you add something to your DOM, if you delete something from your DOM, it just remains as is. If you delete something, however, Preact will go and try to add it again. So this did speed up things a lot and is now very comparable to what React does. We started Preact with a very small footprint, like somewhere very close to 3, and then as we shipped more and more features, we started seeing an increment in our file size, the Preact file size. But now with these new systems in place and all the new things that we have done and a lot of code golfing from some brilliant core team members, we have shaved it down to 3.6 KB. Preact X when it will come out, and just a spoiler, it's coming out really soon, will be 3.6 KB and 900 extra bytes for if you want to use hooks. Okay, so with all this effort, Preact X now brings you support for fragments, hooks, lazy component, error boundaries, and a lightweight suspense. The suspense is not exactly compatible, but if you are using suspense for lazy component, if you're using suspense for most obvious use cases, it will be fine. There are edge cases that we have discovered, and there's like ongoing work on how we can make it more and more compatible with the actual React suspense. But you should, like most of the use cases should be just fine. With all these features comes the nuance of debugging. Obviously, like with the motive of keeping it just at 3 KB, we changed a lot of stuff. Like the V node, which is the leaf element of a VDOM, looks very different than a React V node. And with this problem, we also tried to make our current V node, work with React Dev tools. We accomplished a lot, but it was not where we wanted to be. So Marvin, who is also a core team member and is actually leading this effort of Preact X, developed Preact dev tools. So if you're using, like if you're writing Preact for your whole of the project, you might want to use Preact dev tools, which will also come as soon as Preact X hits stable. Before moving forward, I would like to thank all the contributors to the Preact library, who, small or big, all contributions are welcome. There are a bunch of issues out there. If any one of you wants to go and get started with it, please get in touch with me, or there will be a Slack link at the end. However, history has proven that a great library does not guarantee you a great web app. React is great, Preact is great, Woo is great, but it's very easy for the current web ecosystem to mess up things. Like, as a web developer, it's very, very easy to create big, giant bundles and mess up your user experience. Our team at Google found out that adding a meta framework, established meta framework, can improve your web app's time to interactivity by around 15% at least. The top data shows time to interactivity. The green bars are time to interactivity with a meta framework, and the bottom one is average without meta framework. These are taken by crawling a large number of websites through a lot of tools. I'm not completely sure which ones are they, but that's the data. With that shared vision, we maintain a meta framework of our own called Preact CLI. It's your PWA partner, as we like to call it. It guarantees 100 score on the Lighthouse for whenever you scaffold a project with it. All you have to do is npm install global Preact CLI and then start using it for building your project, for scaffolding your Preact projects. So what does this thing do? It removes the setup pain. As the industry knows, setting up a web project has become overly complicated than we want it to be. So Preact CLI configures Webpack 4 for you. That's the current stable form of Webpack, which means your product team can now actually focus on product and not configuring Webpack. It gives you automatic pre-rendering. Every page that you build will now be automatically pre-rendered. This basically fills the gap of your project's first paint and the needs of your SEO. Third one is pre-configured styling. Your team can choose the styling stack. Sass, Less, and CSS module comes in build. All you have to do is install the dependency, but no configuring overhead for your team. Pre-configured dev servers, so like your UI developers and your UX designers can sit and spend hours for that pixel perfect design of yours, and they don't have to like go back and forth, build it, refresh it, and all of that. They can just sit and argue with each other how is it not pixel perfect. Next is out-of-the-box support for images. The scaffolded project will support WebP, JPG, JPG 2000, GIF, and every other image format that is allowed on the web. And support for Markdown. If you're using it to build your blogs, you don't have to like beat your head around what to do and how to configure Markdowns. You just have to import the Markdown file, use it just like a React component, and it'll be rendered for you. While these are all great features comes with a cost. And thus, as a meta framework, we need to do a lot to make sure that your performance is on track, because our primary promise was to keep you on great performance on a 100 Lighthouse score. For performance, we do differential builds and differential delivery with module, no module technique. This basically means all of your users using modern browser will get ES6 or ES 2015 plus code, while the legacy browsers will get the regular ES5 code. So you can be rest assured that you are not over-transpiling your code and sending more bytes than should have been sent. Next is automatic route-based code splitting. Every route in your app is automatically code splitted. So you can have 100 routes, and none of those routes will bloat each other. Inline critical CSS, this is, if you have built a web app and if you have tried it on web page test or Lighthouse, you know that this is very important for your first paint, for first contentful paints. So Preact CLI automatically checks for every route, takes out the critical CSS and inlines it in the head. Preact CLI also brings offline support with Workbox. All the apps that are scaffolded by default works offline with the app shell pattern. All the UI that you build will be available offline. However, the data you might need to configure because as builders of a meta framework, we can never tell where or what API you guys are hitting. Next, a lot of projects have already started doing similar differential building and differential delivery, but we also do differential compression. The compression of your ES5 code is done in a different way, and your compression of ES 2015 plus code is done in a different way with Cursor, so that if you are doing certain things which can be optimized in an ES 2015 code base, it will be. For performance freaks who want to know what is exactly in the bundles, we generate Webpack stats JSON. So you can just upload it to any Webpack visualizer out there and just see what exactly is going in which bundle of your app. This is really helpful if you want to know, like, hey, why is suddenly my app like downloading MBs of JavaScript? Most used APIs like fetch and promises are already polyfilled for a legacy browser, so that you don't have to go and pick from 10,000 NPM modules which one to use and will it work or not, will it be compatible with my code or not. We already polyfill these most used APIs and send it to the browsers who need it. We don't download these polyfills for modern browsers or browsers which already have these APIs. Okay, so all you have to do is to choose a template with this command in your command line, Preact create the name of the template and the name of your app, and everything will be scaffolded for you. We have three main templates. First one is default. It comes with Preact router and just a simple demo app. You can also do Preact create simple and your app name, which means now everything is up to you to choose. Like, you can do React router, you can do Reach router, you can do Material UI, and whatever, and design, and whatever fits your needs. But this will only come with one index.js file written hello world inside it, and everything is for you to choose. The last one is my favorite. This is the material template. This comes automatically with the Preact router and the material UI. The material implementation is again Preact material components. So you can be rest assured that every component strictly adheres to Google's guideline of material components. However, these are three main components, but there are a few other things which these templates bring to the table. These templates are the reason why how we can guarantee a 100 score on the Lighthouse. Also, you can make your own templates. Scaffold a template, just make some changes to it, and host it on your own GitHub. For example, my GitHub has this template called Material Ducks. I'm a big fan of Material UI and Redux. I should make, after this conference, I should also make Material GraphQL. But yeah, for now, this is just Material Ducks. And you can create your own if you have a preference. All these templates are automatically upgraded to whatever latest CLI versions we push out there. So you can be assured that if you just upgrade your Preact CLI, everything will be upgraded for you. A sample trace, if you want to go and see what it actually looks like, you can go to this link, cli-demo-next.preactjs.com, and you will see that it's an all-in-all 100 on performance. Thank you. This screenshot is taken from web page test, which means this is not a simulation of like a slower device and a slower network. This test is actually done on a real device of Moto G4, yes. and on a very real network of around a slow 3G. Okay. However, these things are cool. There are, as soon as we hit stable v3, which will be the next stable version for Preact CLI, we already have a roadmap for v4. v4 would look, and these things would be somewhat in v4. There will be a plugin-based CLI. Right now, everything is governed by templates. You cannot go and choose if you want material, if you want Redux, if you want GraphQL. So we will be introducing a plugin-based CI in the next version where you can go and just choose what you want, and we'll scaffold a template according to that. Our Preact service worker helper. So while moving from service worker toolbox to workbox, this automatically became a breaking change for us because now developers have to write workbox instead of SW toolbox. So now we are introducing Preact service worker helpers so that one line or with very small code, you can do most of the common stuff like offline caching, offline routing, some runtime strategies. But for niche use cases, you will still need to go and write the underlying library. So what we are trying to do here is like for 90% of our users, changing the underlying service worker library will no more be a breaking change. Third one is better modern JS optimizations. We are already shipping modern JS for modern browsers, but we are continuing our work on how we can make it even more smaller. Progressive hydration out of the boxes. This is like really, really nice, and a lot of talks have talked about it. How there's an uncanny valley. If you do a server-side render and you send it to your client, the client has to download the JavaScript, parse the whole file, and then execute, like hydrate whole of your page, add event listeners, add interactivity to whole of your page. We are experimenting with progressive hydration where the ideas are still up in the air, but you can take as an example, only the page in the viewport will be hydrated, which is like super quick. And the rest of the page will be hydrated as the browser gets idle time for itself. Last is data provider for hydrating pre-render pages. Like if you pre-render the page, hydration currently is a problem which a lot of static site generators deal with. So there will be a data provider using which you can just hydrate the pre-rendered pages. Last one is Preact Material Components. Preact Material Components is a thin, opinionless wrapper around Material Components web. Whatever Google built, we built a small wrapper around it, and then we shipped it. Material.preactjs.com is where it lives. But the next version, you can take a look at pmc-next.netlify.com. It's in alpha right now, and we are still working on it. But now, as you see on the screen, we have started to have opinions because everyone else has opinions on the internet. But actually, the reason is we feel that most components are stuck in 2000. They don't support gestures. They don't support like the modern swipe, zoom, pinch, all of those things. Like the web is still tap me and I'll do something. There's no standard material implementation across frameworks. There's Material UI for React. There's a different implementation for Vue. There's a different implementation for Angular components, and Polymer has its Iron. But there's no standard framework. So like we are adopting the one imperative framework built by Google, and we are working on it so that the definitions remain exactly same. Fragmentation in design system language. The material team at Google publishes a guide, what material design is, and a lot of products, a lot of design systems just read that guide and try to infer their design system on their own. So there's a fragmentation. A material button from 4 different libraries may look very, very different. So that's what we are trying to solve with Preact Material Components as we are using the same underlying library. To offer best performance for these components, we made sure that the monolithic package that we are shipping till now is now broken into smaller sub-packages, namespace packages, so that even if your bundler is not great at tree shaking, this thing is already doing tree shaking, or at least component-wise tree shaking for you. There's a generic event and props delegation layer so that all components will have a very similar feel of API, where you want, in an event listener, if you expect details of that event to be. Like it will be the same location for button, for drop downs, for sliders, and everything else. And all these modules will also publish modern ES 2015 plus code so that you can pick that code, and Preact CLI can also pick that code and decide, hey, I don't want to transpile this anymore. This is the problem with a lot of published packages, that they are just published in ES5, so you just can't help it. Like even though your build system do differential build, but it can't upscale from ES5 code to ES6 code. To offer best UX, all these components will have all modern gestures enabled for them. There will be an integral theming support so that your team does not have to spend hours for that dark theme feature request from your product manager. There will also be a well-defined Sass and CSS support, so it can align well with your tech stack. So, of all of this, if you are excited, how do you try this awesomeness out? So, all you have to do is like npm I Preact at next, Preact CLI at RC, and Preact router at next. These three things, along with Preact CLI, will put you on the edge. Like, will give you an experience of beta versions or Preact X coming out. Last up, we love feedback. If you guys have tried out Preact X, if you guys already have a Preact code base, and you try Preact X and find something not working, do give us a shout out at preact-slack.now.sh. We want to hear everything, the good, bad, and the ugly. We already know a few things which might not work out, so we'll be more than happy to work with you. Thank you. That's all I had.
This video recording was brought to you by Twilio. We allow you to integrate different means of communication such as video, chat, or SMS into your React applications. If you want to learn how you can send SMS directly from a React chat, check out this video on the right or go to our Twilio YouTube channel. And if you want to watch another React India talk, we picked one out just for you over here on the left. Thanks for watching.